Let's write the chemical equation for the dissociation of each of the following acids and bases in water. All right, A, nitric acid is one of the 7 strong acids, and that is HNO3. Because it's a strong acid, when we put that in water, it's going to completely dissociate, so we'll just use an arrow to the right. In essence, 100% will be these hydrogen ions and nitrate anions. So there it is for A. Then let's move on to B. Ethanoic acid or acetic acid is a very common weak acid. A couple ways you can write this formula. You have CH3 and this carboxyl group here, COOH, and so it's this H that is going to dissociate. This is a weak acid, so when we put that in water, we are going to get an equilibrium. The equilibrium position will lie far to the left, so most of this will remain non-dissociated as ethanoic acid, but we are going to get a little bit of hydronium ions and then the conjugate base with the lost proton. And then ammonia is NH3, and when we dissolve that in water, H2O, it's a weak base, so we're going to achieve equilibrium, and because this is the base that's going to accept a proton, that's what a Bronsted-Lowry base does. It accepts protons, and the only thing other than the ammonia is the water, so water is going to be the Bronsted-Lowry acid. So when ammonia accepts a proton, it'll be NH4 positive, and that's the ammonium ion, and H2O is lost in H, so that's going to increase the concentration of OH. All right, magnesium hydroxide, not the most soluble thing in the world. There's your Arrhenius base. But to the small extent that it does dissolve, right? So magnesium hydroxide, first get the formula unit. Magnesium has a 2 positive charge, and hydroxides have a 1 negative charge, so you'll have to use those ratios to get the formula unit. All right, but the little bit that does dissolve is going to completely ionize. The group 1 hydroxides and group 2 hydroxides are strong bases, though. Now group 2 hydroxide compounds, most of them don't dissolve very well. But you're going to get the magnesium ion, hydroxide ions. What am I doing here? Strong acids and bases, they'll have their equilibrium position far to the right. So that's how you associate these acids and bases, and just a lot of these are very common ones for you to get familiar with.